So today we're talking about the use of statistics to improve the integrity of research data. Yeah. Now, any statisticians in the room? There's one at the. You're a statistician. When do you usually get involved in research? Do you do your own research in biostatistics? But when others ask for your help, when do they come to you for help? Yeah.
Or after collecting data.
Yeah.
So sometimes coming.
Okay. So there are two times that you're mainly involved in research. That means at the very beginning, when they say, usually it's a sample size estimate, isn't it? And the answer is always 100, isn't it? You know, they tell you, I've got 100 patients. What's my sample? You know, can you make my sample size estimate? And so you have to make a big effect. So it comes. So usually statisticians are involved at the very beginning, and to help with sample size estimations, and at the very end to help analyze the data. But what I'm going to make the case for is actually the important but neglected role of statisticians in the middle, yeah, during data collection. I think that's a really important place for statistics to be involved, and that can improve the quality of the data. Yeah? So it's about using statistical methods to check the validity or the accuracy of the data as you're going along in a study. Yeah? So I told you about this study that I'm going to start from the beginning about the way you can use statistics to help check the data integrity. So in 2009, I mentioned this paper the other day. In 2009, we wrote this systematic review of tranexamic acid in postpartum hemorrhage. And we found all of these trials, and we concluded, and we believed everything that was written on the paper, and we believed that tranexamic acid reduces blood loss. And then, but since then, we've become more skeptical. Now, we talked about this, about the most important. This is a randomized trial, very simple structure, and we talked about the key element of a randomized trial is this. It's the randomization and allocation concealment. And I think it was Tomoko who said that the key word is unpredictable. Was it you? Yeah. So that's the most important thing. The allocation must be unpredictable. Yeah. So that's really important. So if the allocation is unpredictable, then chance and chance alone determines who gets into these two groups. Yeah? And so these two groups should differ only by the play of chance. Yeah? There shouldn't be any differences. There can be differences, but they're chance differences. But there shouldn't be differences over and above the play of chance. Now, we do, I love randomization because of its fantastic ability to balance baseline variables. So in this big trial we did of tranexamic acid for the treatment of traumatic hemorrhage, you know, this woman's been shot or stabbed in the stomach, and so she's been randomly allocated to tranexamic acid or not. And this is the first table in any research paper of a randomized trial. It's the baseline comparisons. So it's comparing those who got the treatment and those who didn't get the treatment, so the drug and the placebo group, before they've received the treatment. Yeah? So you collect the information, you've randomly allocated them, and you're just looking at the baseline variables. Yeah? And it's fantastic. You know, it's beautiful, I think. they're so beautifully balanced, you know. All of these factors, I don't know if you can see it from over there, it's quite difficult to see. But all of these things are, you know, really well balanced, you know. 15.5% had a low blood pressure, 15.9% in the placebo group. Really, you know, so you get a really nice balance. So randomization, when it's done correctly, is really beautiful. So if you do proper randomization, you'll get two groups that differ only by chance, yeah? And who is talking about doing meta-analyses of studies and finding out that they weren't, you did a meta-analysis of studies and then you found that the studies weren't, wasn't, yeah, so what really happened wasn't mentioned in the paper. Is that what you found? Tell us what you found.
Was not written in the paper.
Yeah.
They wrote that they did a randomized control trial.
Ah, that's it. Yeah, they used the word randomized controlled trial, but they hadn't really randomized. They were either confused or...
Actually,
It was intentional, okay.
otherwise the paper wouldn't be published.
Ah, I see. Okay. All right. So, this is a good trick that you can do to see if studies are really randomized or not, right? So, if they're really randomized, then the two treatment groups should differ only by chance. And if you do a meta-analysis of the baseline variables, yeah? Now, usually we do a meta-analysis of the outcome variables, don't we? So, you know, you want to know if this treatment has an effect. So you do a randomized trial, you randomize this, patients get this treatment or that treatment, you follow them along, you get the outcomes in the two groups, and you do a meta-analysis of the outcomes to see what effect the treatment had. Well, now we're doing something different. We're actually doing a meta-analysis of the baseline variables, yeah? And we shouldn't see any average difference, should we? Yeah? And we shouldn't see any heterogeneity over and above chance, yeah? There shouldn't be any heterogeneity. Do you know what heterogeneity is, everybody? Heterogeneity is like sort of variability over and above chance, yeah? Callistus? Yeah? So you shouldn't see any overall difference and you shouldn't see any heterogeneity. So we went back to this meta-analysis we did of tranexamic acid in postpartum hemorrhage, and we did a meta-analysis this time of the baseline variables. We had done a meta-analysis of the outcome variables, but now we were actually wanting to learn, actually, were these really randomized trials? Let's do a meta-analysis of the baseline variables. So we took two key variables. Age is a good one. Age is a prognostic factor for lots of things, and it's used almost always age is one of the baseline factors. So you can do a meta-analysis of age. So we did a meta-analysis of age, and there was the patients in the treated group were significantly younger. That's a bit, so that shouldn't really happen. I mean, maybe it could happen really rarely by chance, but it shouldn't really happen. It makes you a little bit more suspicious. So there was a significantly lower, age was significantly lower in the treated group, and an important one considering the outcome is blood loss, the baseline hemoglobin, so that they're trying to see if tranexamic acid reduces blood loss, and they're measuring the difference in the baseline to the follow-up hemoglobin. And so the baseline hemoglobin was much lower in the treated group. I'm not sure what direction. Anyway, it should be the same, ideally, but it was different. And also there was significant heterogeneity. these differed more than you'd expect by chance alone. So, so that's a bit strange. So that made us a little bit more suspicious. Now, this is new stuff. People recently have started using statistics like this. What you do is you take all of these trials and you work out a t-test. Yeah? Everybody familiar with a t-test? It's a t-test for the difference. It's a significant test for the difference in the baseline variables. The mean difference, the t-statistic, and the absolute value of the t-statistic. And then you rank the studies by the t-statistic. So you rank the study by the size of the difference between the groups. And then you delete them one after another until you get zero heterogeneity. And then you do a meta-analysis of those studies and see what they show. Yeah? So it's like doing a sensitivity analysis. It's like saying, okay, if these studies are properly randomized, chance and chance alone should determine who goes into the both groups. We can get differences in the baseline variables, but they'd only be due to chance. And if you do a meta-analysis, you shouldn't see very big differences. But if you do see differences, then you can exclude the studies based on the size of the differences and then do the meta-analysis again and see what effect it has on the results of the meta-analysis. Is that clear? It's a bit complicated, isn't it? What do you think? Tomoko, in your meta-analysis, tell us about your meta-analysis. What were you doing?
It was about to assess the effect of kind of
Extracorporeal.
circuit for a severe critical ill patient.
Yes.
And there were 12 studies
Uh-huh.
conducted, and 6 of them were from the same one group. And those 6 studies were very small.
Yes.
Small sample sizes, and their description in papers were very ambiguous, and I cannot find out what they have done clearly from the paper. So I asked them what they have done
Yeah.
in their studies, and found that they have not done randomization,
Yeah.
but they wrote intentionally that they have done randomized control trial.
Yeah.
He said that it's because of the paper to be published
Ah.
in the journal.
Well, you had a very honest.
But they didn't answer to my email.
Yeah.
They didn't write.
Oh, it was when you called them, wasn't it? And these were researchers in Japan. Okay. And you called them and they said, oh, it's because it wouldn't get published otherwise. Okay. And what did you do afterwards? Did you do anything?
I excluded from my analysis because it is not a randomized control trial
Hmm.
for my research.
Yeah.
And because after I wrote that, actually it's not published yet, so I cannot say everything I wrote. I excluded 6 studies from this analysis because we found that was not a randomized control trial after the inquiry analysis.
Yeah. Okay.
Yes, that's.
And you'll leave it there.
I don't know because it's ongoing. Meta-analysis is ongoing.
Hmm.
And my paper is not published yet, so I don't know what the reviewers will say about that, or scientific community,
Yeah.
our community, our scientific
Yeah.
community will say about that, because
Ooh, it's an interesting one, isn't it?
yes,
Who think?
it's a little bit scary.
What do you think Tomoko should do? Has she done enough? Now she's identified these studies as not being randomized, and she knows that they were said to be randomized so that they could be published. And it was intentional. So it puts you in a difficult position now, doesn't it? I mean, in a way, I mean, it's difficult or easy depending on how you want to do it. You can say, well, okay. But what do people think? What's her responsibility? Or does she have a responsibility here? What do you think?
I don't understand. Because she wants to, she can try, because she like to explore that. I think she has the right for that as a researcher.
She has the right to expose it.
Yeah, if she wants.
Yeah. And what will happen to her if she does? Yeah. So was this a university?
The researchers'
Ye-
affiliation?
Yeah. I mean, they were local hospitals. Okay. Yeah.
I think it's dangerous for her.
You think what?
Yeah, I think it's dangerous
It's dangerous for her.
for her to write such words in the paper.
Yeah.
Since if other readers read this, and they would all think, oh, if anyone call me and ask me my trials, I will not be honest anymore.
Oh, I see.
Then also with the phone call there is no evidence. She cannot
Yeah.
provide any evidence. So
Actually,
the
a
all
phone
task
call,
are
if
just
you want to
case.
record the phone call, is an evidence.
Yeah, but maybe she did not give this. I don't know.
Yeah.
Without consent, right?
And you don't know what they're going to say in
Yes.
advance. I don't know they're going to say such thing. So
Because
why would I
even-
record all my
Even if you write like a letter to the editor, maybe,
Mm-hmm.
but you don't have you have nothing to cite for.
Yeah. I mean, I think what you've done is, I mean, most people would think that's reasonable. You know, you've put it in the paper that they, you know, you've investigated and you found they weren't properly randomized. It's a very difficult one, isn't it?
But the question would be in your manuscript, did you include reference to those studies that you didn't include? Because if you just say, I excluded a number of studies because they were not randomized, but me as a reader don't know which studies are these studies.
Of course.
Oh, you okay. Well, at least that's something. I mean, if I'm in the same area, your same research area, and I read your paper, I will check which ones were excluded because they were not randomized. At least it's something.
Maybe. I think other people will do a meta-analysis and they'll include them because most people take them at face value. So they're little bits of dangerous material in the literature. I mean, if they're not randomized trials and they're called randomized trials, then maybe they should be retracted? No? You don't think so? You disagree? They should be taken out of the literature, you know.
They should.
They should.
But some of my colleagues said that they were already academically retired, so
Ah.
not interested in.
Oh. Well, they might have retired, but the paper's still there. The paper won't be retired ever. The paper will be there for all time.
Another problem is those studies have already included in the previous systematic reviews.
Yeah.
So
It's very difficult. It's very difficult. In fact, I think I told you about this one. So you know, these are the studies that we found in this meta-analysis, and we found out they had all of this same mistake, and then we looked at the papers, and they were all the same text, and then we found that they had the same results. And then we wrote this paper, does tranexamic acid, and we changed our previous conclusion. We said, in 2009, we said tranexamic acid reduces bleeding after postpartum hemorrhage. But this time, we decided to tell the truth. So we wrote this paper, and we said, there is no evidence that tranexamic acid reduces bleeding in postpartum hemorrhage. Most of the trials, a large proportion of the trials, are fraudulent. What happened? So we wrote that. We wrote our evidence. We showed that we showed the baseline variables. We'd written to the authors, asked them for the data. We'd checked the data, found it was wrong in many cases. We asked them about ethics committee approval, and then we checked with the ethics committee, and we found many cases where there was no ethics committee approval, and they said there was. And then we asked the authors, and they said, well, actually, no, you're right, we didn't get ethics committee approval. So, we had all of this, and so we said, let's just tell the truth, and let's just tell exactly what happened. So we wrote a paper saying exactly what happened, and we sent it to the Lancet. So what happened next?
More enemies.
What? Well, what did the Lancet decide to do?
I think it should normally publish the paper.
Yeah.
And also take steps to investigate if
Mm.
some of these papers were referenced to were published in the Lancet. Normally it should take steps to retract them if the fraud is real.
Oh, they weren't published in the Lancet. We wanted to publish a systematic review in the Lancet showing that previous research was fabricated, was fraudulent. So what would the Lancet say yes to this, or what would it say?
If you have evidence, I think we will say yes.
Really? So you're the editor of the Lancet, right?
If you have enough evidence to make
Oh.
them believe.
All right, let's do a role play. Right, Callistus, come and sit here. You're the editor of the Lancet. So Callistus is the editor of the Lancet. Who wants to be Callistus's Bengoshi? Yeah. So you could be Callistus's Bengoshi, right? And then we say, editor, here's a paper. It shows that these studies were fabricated, and we think they're fraudulent. We think it's important to tell the truth. What are you going to do?
Thank you for submitting your manuscript.
He's an expert lawyer. They all say that. Yes. Right. What's going through your head now? Now you're the editor of the Lancet. What's going through your head?
Unfortunately, we receive many papers.
Ah, yes. You must have been rejected many times. He knows all the words for the rejection. Unfortunately, we received so many papers.
Well, I think if I'm the editor, I'll share it with the editorial committee.
Yeah.
And make a decision. I think it's difficult to really decide.
Yeah. And what would your lawyer, what would you be saying to him? He's thinking about publishing a paper that claims that other research is fabricated.
I think it's the risk to engage in such a manuscript is that it can be very controversial and it can elicit a lot of reactions, and sometimes a journal doesn't want to be involved in such issues. They want to keep a good reputation and everything. So,
Well, I mean, what's the actual risk? I mean, I think you're talking now. you're the lawyer working for the Lancet, and the editor's thinking of publishing a paper. You're the lawyer. What are you worried about? What's the risk that you're worried about?
Worried about being sued, complaints from.
You're worried about being sued. Okay. So what do you say to the editor?
To avoid problems, to politely reject the paper.
Reject the paper.
Just in case we don't have all the evidence really showing that those research were fraudulent. So
Yeah.
I would suggest that we don't get involved in that.
You would suggest you don't get involved. Okay.
But I stand for telling the public the truth.
Yeah. So we've got Callistus, who has got a social value of wanting to tell the truth, but your lawyer is saying that this is putting your journal at risk, and maybe putting your job at risk. You know, if the Lancet gets sued, you might lose your job. So now you've got to weigh your responsibility to the truth against the possibility that the journal, under your, as a result of your decision, might get sued. What do you think?
I want to look at the evidence that the authors have.
You want to look at the evidence that the authors have. Okay.
Get advice from my lawyer whether this evidence can stand in law court.
Okay, so that's very sensible. He wants now to get advice from his lawyer about this manuscript. So this manuscript's become a very special manuscript now. It actually has to be legally defensible, yeah? And the lawyer is going to advise on this. And what sorts of things? You'll want evidence, won't you?
Yes, yes.
Yeah. Everything that's said in that manuscript, you'll want to see the evidence.
Not necessarily everything, but at least if I can have some documented proof where authors are recognizing that they have manipulated data, like in their case it was a call phone, but if it could have been written, that would be something good, because I have a document where they're showing that they did something
Yeah.
wrong, and
Well,
this can be exposed in the courts.
so what Tomoko says is that she rang up the authors and they said that they said it was randomized in order to get the paper published, but in fact it wasn't. Is that evidence?
On the personal note, yes, but in terms of the law, I wouldn't dare going with that, because it's going to be my word against theirs, and
It's going to be Tomoko's word against theirs. And when challenged, that you could pick up the phone and say, no, we never said that.
Yes.
I didn't say that at all. So it's getting more complicated, isn't it? Now, how do you make a living?
defending people.
You make a living defending people. So you're giving this advice to the Lancet. Are you giving it for free?
I'm being paid.
You're being paid. So the Lancet will have to pay you for your time to review this manuscript. And this manuscript's going to require a lot of work, isn't it?
Yeah.
And you're going to charge by the hour to the Lancet, aren't you?
For sure.
So it gets more difficult for Callistus now, because Callistus now has got to think, right, if I'm going to accept this paper, I have to pay legal fees to my lawyer to give me advice on it. I risk being sued by the angry researchers. I risk, there's a risk I could lose my job. What are you going to do?
This is just one of the 1,000 papers.
And this is just one of the 1,000 papers that come across your desk. See, Callistus made the right decision the first time from his point of view, didn't he? He says, unfortunately, we get a lot of papers, and yours isn't, you know, despite being very interesting, we read it with great interest, you know. They just take one look of it and say, no way am I going to publish this, yeah? And that's what always happens. So journal editors, when they get a sense of any misconduct, they will always reject. If you're alleging misconduct in a journal article, thank you, Callistus, that was you did a good job. They will always reject, you know, because it's not in their interest to do anything otherwise. And so why does the public think that science is self-correcting? You know, the public thinks that if something is published and it's wrong, that actually other scientists will make that known and it will get corrected. That's the general view, isn't it? That's what scientists claim about research. You know, the good thing about peer-reviewed research is actually if something goes wrong, you know, other people will tell us about it and it will improve, yeah? But is it true? It's not true at all. It's completely the opposite. Everybody wants to hide it. You know, absolutely everybody. I've gone off statistical data monitoring, but this is, you know, but you won't. So we tried to. This paper, so the Lancet said they didn't want to publish the paper because, and they said, you know, we should take it up with the universities of the authors involved. So we did do that, and the universities, I wrote to all the universities of the authors, and they don't even write back. They don't even write back. So the universities, why would they write back? You know? So they go, oh yes, how interesting. One of our researchers, you're accusing one of our researchers of fraud. Oh, we'll look into this. No, they don't do that at all. They just ignore you, you know. And like I did, I went away because, you know, I haven't got time and money to investigate. It's not my job. So we found a journal that had published these papers without noticing their flaws, and it was an obstetrics journal. And I said to the editor, it was an editor I knew, and I said, you know, these are wrong. You know, the conclusions are unreliable. But they agreed to review the paper. It did go out to the lawyer, and the lawyer took all the strong words out of it. So we didn't say, you know, so it ended up existing trials are unreliable with serious flaws, you know. That's where we came to at the end, you know. So they take all of the anything controversial out of it. So it's I think it's a broken system, really. It doesn't work very well. Anyway, back to statistics. So this use of p-values is very interesting. So who can tell me what a p-value is? It's a kind of, it's quite often misunderstood, p-values. Does anyone want to have a go? Everybody's getting very nervous now because everybody feels they should be able to explain a p-value. When we interview staff in my unit, I ask them to explain a p-value. And you know, they have master's degrees and PhD degrees, and they can't do it. Anybody want to have a go? Do you want to have a go? P-value?
I use p-value when I want to compare two groups of more groups.
Yeah, that's what they're used for. But anybody can say what they are actually?
The first step is I null hypothesis.
Yes! Yes, that's it. Right, she's got it. I'll give you a job. Most people get that wrong. So you always start with a null hypothesis, right? So the null hypothesis, in a randomized trial, what's the usual null hypothesis?
The null hypothesis that there is the baseline, the two groups, they have no difference.
The null hypothesis that the treatment has no effect.
Oh,
Yeah? Yeah. So there's no effect of the treatment. So the outcomes, so if you randomize two people to get a drug, not to get a drug, and you follow them up and you see a difference, the null hypothesis is that the treatment has no effect. Yeah? So you've started in a really good place. You start with the null hypothesis. So whenever you see a p-value, that's the question you've got to ask. What's the null hypothesis? Yeah? And that helps you to understand the p-value. So the p-value then, see if you can keep on going. You're doing well so far.
First we put out the null hypothesis.
Yeah.
For example, the outcomes of two groups have no difference.
Yeah.
And then we the two groups have their outcomes have distributions, and we want to compare their mean distributions, have their distance is significant or not.
Yes. So first of all, you have a null hypothesis. The null hypothesis is that there's no real difference.
Yeah, no real difference, and the mean.
And then you've got some data.
Yeah, I got some data. Difference is about mean difference.
Mm.
The null hypothesis, the mean difference is a distribution of 0. But when we get the real data, the two groups, their mean difference may be distributed from the 0.
Yes. So you've got a null hypothesis of no difference. Then you get some data, and there's a bit of a difference.
Yes.
Yeah? And then the p-value is, if the null hypothesis is true, what's the probability that I would get results as large as a difference as large as this by chance alone, isn't it?
Yeah, by chance alone.
Yeah? So when you start off with this null hypothesis, and then you've got some data, and you're saying, if that's true, how likely is this data if that's true? And so if you've got a small difference, then it's quite likely. But if you've got a very large difference, it gets less and less likely. So the p-value is the probability that if the null hypothesis is true, that you'd get results as extreme as the ones you've got. Yeah? So if you have a p-value of 0.05, what proportion of results are compatible with chance alone?
5%.
5%. Yeah? Everybody agree with that? If the p-value is 0.05, then there's a 5% chance of getting a result as big as that just by chance. Now, if the p-value is 0.1, what's the probability of getting a result like that by chance alone? 10%. If it's 0.15, what is it? 15%. If it's 0.2, all right, you've got it. So the p-value should have a uniform distribution, yeah? So we've gone 0.5, 0.1. So, you should have the same chance of having a p-value of greater than 0.8. The same chance, you should have the same chance of getting a p-value of greater than 0.8 as getting a less than 0.2, yeah? Because the distribution is uniform, yeah? Do you get that? Everybody? Bit complicated? So the p-value should have a uniform distribution. Now that's been used very well. There's a very have you heard of Yoshihiro Sato? No? Mitate Hospital? Anyway, it's a kind of reasonably well-known, for people who are interested in misconduct, it's a reasonably well-known case of misconduct. It's a researcher in a hospital in Japan, and he researches on a drug to increase bone density, yeah? And these are, and he makes randomized trials, and somebody looked at the distribution of p-values in his randomized trials. The distribution of p-values for baseline variables, yeah? And this is the distribution of p-values for baseline variables. So what do you notice about that? So basically they looked at one variable, say age, and looked at the p-value, and then recorded it, and then, you know, and he had lots and lots of trials and lots of baseline variables, and this is the distribution of p-values for baseline variables. What does it show? What does it look like? Anybody? Well, I said that it should have a uniform distribution. Does that look uniform? It's skewed, isn't it? Someone said skewed. And which direction is it skewed in? Yeah, the p-values tend to be very close to 1, don't they? Now, I told you that the distribution of p-values should be uniform, so we should expect the same number of p-values to be between 0.8 and 1 as to be between 0 and 0.2. Yeah? But it doesn't look like that, does it? We've got lots of very high p-values, you know, and not very many low p-values. In fact, what this researcher did is they compared the kind of I don't know how they did it, sorry, but they said, well, look, we should expect a uniform distribution, but we've seen this distribution. How likely is it to get a distribution like this if the real distribution is uniform? And it was really small, you know, 3.8 times 10 to minus 100. Yeah? So then they challenged this Sato, this statistician, said to Sato, these p-values don't look right. They don't look like they've been, you know, all of the p-values are too high, you know, like looking like there's very little difference in baseline variables. You should have had more extreme. You should have lower p-values. And then he acknowledged he made them all up. So he'd made up 33 randomized trials. And so basically he sat in his office and he wrote down, you know, like when you're doing a trial, you know, you have your table 1, baseline variables. So he put some numbers in, you know, maybe he had a calculator. Anyway, they were all made up. And it was discovered because of this, using the baseline values. Baseline values are really important in detecting fraud.